Hello class, today we're going to be doing graphs of functions. So when you're doing a graph of the function, the graph of a function is the graph of its ordered pairs. Let's demonstrate that with a simple line. Let's pick a color here. So let's do the function f of x equals 2x. F of x is equal to 2x. So I'm going to do an x and y table so I can get some of the ordered pairs. And let's pick some values for x. Let's choose -2, 0, and 2. -2, 0, and 2. When I put -2 in, 2 times -2 is going to be -4. 0 times 2 is going to give you 0. And 2 times 2 is going to give you 4. Now I'm going to attempt to draw this line on my graph, but keep in mind I'm drawing on a computer without a ruler. You can use a ruler. So make sure you find those points. And pretend that that's a straight line. Hopefully yours looks a little better than that. So let's do another example. Let's change it from f of x to g of x just so we have something a little different. So g of x is equal to 2x minus 3. Ooh, we added a little something. Let's go ahead still and do an xy table. And let's use the same points, 2, 0, -2, 0, and 2. So -2 times 2 is -4. Then we're going to subtract 3, so that gives us -7. 0 times 2 gives us 0, and then we subtract 3 and we get -3. And 2 times 2 is 4, and you subtract 3 and you get 1. So I'm going to graph these points, and yeah, I'm going to be trying really careful to do that line, but pretend that those go through the points I just named. These are supposed to be parallel lines. So they're parallel because they have the same slope of 2. And this little part right here, I added onto that f of x, and that's really a transformation of f of x where we shift that line down by 3 units. Okay, 3 units. ITS. So as I keep writing on this, I get a little pop-up thing that says, hey, do you want to skip to the next slide? I'm like, no, I want to just keep writing. So sorry about that, and hopefully this slide will be done doing that now. So if we have a graph that you've got 4 graphs down there, so if you want to know whether or not they are graphs, we're going to use this thing called the vertical line test, sorry. So use the vertical line test to identify graphs in which y is a function of x. So here's how we use that. If a vertical line intersects the graph, in more than one place, then the graph does not represent a function. Graph does not, D-O-E-S, not define y as a function of x. All right, so let's take a look at these graphs. So at any given time, if I draw a vertical line, it's only graphing this thing. It only will touch that graph on one place. So yes, this one's a function. But in this one, I can make a vertical line, and stop doing that. And it will cross that graph in more than one time. As you can see, this time it's 3. So we're going to say, no, that's not a function. This one, yeah, it doesn't matter where I draw it. It never crosses it more than one time. So yes, it's a function. And this lovely circle, okay, that's supposed to be vertical, but you get the idea. It does cross it in more than one time. So that's not a function. Okay, it's time for an example. So if you take a look at the graph there, at the top of the graph, it tells you what that is representing, and it means it's representing the average number of vacation days by how many years a person has worked. So the vertical axis tells us the number of vacation days, and the horizontal axis tells us the number of years that a person has been working for the company. So we're going to use that graph to answer these questions. So the first one says, use the graph to find a reasonable estimate of f of 10. So f of 10, that 10 here, is going to be the number of years working. So if I look at that line right here, where it crosses that graph, and I come across right here, I'm going to make an estimate to the nearest year, and the number of days that it will have, number of days, did I get that line across here? Looks like it's either 16 or 17. I'm going to say it's 17. Now, the next question asks me, for what value of x is f of x equal to 15? So I'm going to look at the vertical axis there for 15. That's this one, right there. And then I'm going to come down, and it's supposed to be a little bit less than that. There we go. And it looks like it's going to be less than 10 years, so probably about 8 years. So I'm going to say 8, oops, not days, years for my answer on that one. Something else that we can find on a function is the domain and the range of the graph. And we talked about that in our previously. So if I have a function, let's say it looks like something like this. And you see this little thing called an asymptote on there, and we've looked at those before. I can look at that graph and determine that what its domain and range is. Now, the domain is going to be the input. And so those are going to be our x values. And this one, oh, let's not make that, let's go red, I'm sorry. There's a dot instead of an arrow so that we can see something, and it just does not want to make a dot. All right, make that a dot, and it's going to be at -3. So it starts, the x values start at -3, and as I move from left to right, it's going to stop at, that's supposed to be at a 3. Now it never ever gets to 3, so I'm going to use a parentheses here, which means that it's not included. But I'm going to use a bracket here because it does include that -3. Now let's take a look at the range. The range is the output. What does the function machine do to the x value? And those are called our y values. And that's our vertical axis. So if we look at what the lowest one is, right here, it's going to be at 0. And it continues to go up forever and ever. So we're going to go all the way to infinity. So it includes this one. So it's included. So I'm going to use the bracket. And we can never quite get to infinity, so that's not going to be included. So that's how we would write the domain and range of this particular function. And why is it not recording? Oh, maybe it is. It says pause. Does it say pause? No. Let's find out. Okay. Sorry about the freak out. Apparently I don't know how to read my own screen. So this is new. We'll figure it all out. All right. Last examples. Let's take a look at these. We can tell some certain things about functions when we're looking at them. And on this one, not only can we find the domain and the range, we can also find the x-intercept and the y-intercept. The x-intercept is where it crosses the x-axis, the horizontal axis, and the y-intercept is where it crosses the vertical axis or the y-axis. And then the final thing they want us to find is f of -1. So we're just going to look at where this -1 is. When x is -1, what is y, is basically what they're asking. So let's take a look at this very first one. I'm going to choose this color. And so the first one, I want to do the domain. I'm just going to use D here. And I have endpoints here. So we're going to go from the x value of that first, of the lowest x1, which is going to be to your, yeah, am I doing it backwards? Okay, so whatever. Anyway, it's going to be the smallest x value that it contains, and that's going to be -2. And I look at that point, and yes, it's inclusive because it's a dot that's filled in. And then the highest x value is 1. So the domain, and that also is included. Now the range, the lowest x value is 0, and it's included. And the highest x value is 3, and that's also included. The x-intercept, it crosses the x-intercept at -2, 0. And then we have the y-intercept, I'm running out of space here, is going to be at 2, so 0, 2. And then I'm going to come over here, f of -1 is equal to, when x is -1, it looks like y is about 1.8. So that's what I'm going to write, 1.8. Let's take a look at the next one, and let's go with that color here. And so on this one, I'm looking for the domain, and the domain starts at -2, but notice it has an open circle. That means it's not inclusive, and it ends at 1, but that one is inclusive. The range is going to feel like you're going backwards, but remember, you're going from the lowest one to the highest one. So the lowest y value that you have is -1, and that's inclusive. And then you go up, and you see that it goes up to 2, but that's not inclusive. Now the x-intercept is 0, 0, and you know what? That 0, 0 is also the y-intercept. So they're both 0, 0. And then f of -1, -1 looks like it's +1. And then let's go to this last one. This one has gaps in it, doesn't it? So if I'm looking for the domain, I go from -3 to -2, but then it keeps going from -2 to -1 to -1 to 0. So, and it kind of does have all of those. So -3, and that's inclusive, and it goes to 0, that's not inclusive. Now the range, that one is different. Notice I have values at -3 and at -2 and at -1, but nothing in between. So it's going to be a set of numbers of -3, -2, and -1. And then let's see, our x-intercept, it doesn't even have a value at the on the x-axis, so we're going to just write none. And our y-intercept, we haven't, right there is a open circle on the y-axis, but that means it doesn't have a value there. So once again, our y-intercept is none. And our f of -1 at -1, it's -1. Thank you for watching.